Welcome students. This video lecture is a part of Fluorescent Public School Digital Learning Program. Today we start our first chapter, Chemical Bonding and the subtopic Lewis dot structure. Today we learn how to draw this Lewis dot structure and what are the laws which are behind this Lewis dot structure or propose these kind of structures. Yes, and goes to the Lewis dot structure of different kind of compounds. Yes. So there is a first theory which was put forward in case of chemical compounds, structure of chemical compounds. You can see here. This is electronic theory of chemical bonding that was put forward by Lewis Cossell in 1916. What is the basic theme about this theory is kernel. Kernel is nothing is just a nucleus along with the electron that are filled inside the shell, innermost shell, inner shell, except valence shell. Okay, so they are called kernel. This theory wants to tell us about why two atoms are combined together to form a chemical compounds or molecule. So this theory gives the basic idea about it. Yes, why atoms are combined together. So the basic logic is that the output of this theory is octet rule. According to that rule, that every atom tends to complete its 8 electrons because after completing 8 electrons it achieves stable configuration just like inert gas configuration. Okay, if we take an example of fluorine, there is electronic distribution that is 2 electrons in innermost shell and 7 electrons in outermost shell. That's why these red color electrons are valence electrons. So if we talk about the kernel, what is the kernel here? So nucleus, yellow color nucleus, along with these two electrons, which are inner shell filled electrons, are called kernel, and the remaining red color electrons are called valence electrons. In case of Lewis dot representation, we represent only valence electrons. Okay, and these electrons are represented as a sphere attached on the corners of a cube. As we know, there are 8 corners in a cube. So, according to Lewis and Cossell, this kernel is represented by the cube, and the valence red color electrons are put on the corners of this cube. Since this fluorine has only 7 electrons, so there is a one corner unoccupied. So fluorine wants to react with some other atoms which can give one electron to the fluorine. For example, fluorine react with the hydrogen and gain one electron from the hydrogen. So ultimately it completes its 8 electrons. Okay, or fluorine may react with the sodium, and sodium has a electron 11 electrons, and it has one more electron in its outermost shell. So sodium give its one electron to the fluorine and react with the fluorine to form sodium fluoride. So this is all are about the uh, reactivity of atoms. Fluorine tends to form a bonds with the other. It's not matter that what kind of bond is formed between two atoms. It may be uh, ionic or covalent. But the thing is that atom react because to complete its 8 electrons or to occupy 8 owners of this kernel according to Lewis Cossell. Okay, so if we want to draw Lewis and Cossell Lewis dot structure, then how we write? I already told you the output of Lewis Cossell approach is octet rule. What it say? Every element wants to complete 8 electrons in its outermost shell called octet rule. Octet means group of 8 electrons. Why only 8 electrons? Because it represents fully filled configuration or configuration of inert gases. As we know, inert gases are quite stable. That's why this octet rule came into existence. You can see here 8 electrons can be achieved by exchange of electrons or sharing of electrons. If atoms do exchange of electron, then the types of bond which form must be ionic. If it completes its 8 electrons or it occupy 8 electrons completely to the corners of the kernel, then the types of bond which are formed by sharing are called covalent bonds. In 1919, by the scientist Langmuir, there is a term which is coined called covalent bond. Langmuir gave this term covalent bond in 1990. What about the covalent bond? The bond which is formed by sharing of electrons. So, by the octet rule, we are we are able to think about the answer of question that why two atoms are combined together. So the basic answer of this question is very simple, that two atoms are combined together to achieve stable configuration or to complete their 8 electrons in outermost shell or valence shell. That can be represented by octet. So we have number of atoms in our periodic tables. I give only 14 elements here. So the basic motto behind this table is we want to we want to draw the Lewis dot structure about these elements. For example, hydrogen is there. If you know the electronic configuration that we already discussed in chapter number 2, atomic structure, then we can easily draw the Lewis dot structure. You can see here the configuration of neon is there. Yes, neon has a 8 electron in outermost shell. That's why everyone wants to complete its 8 electron or octet. Okay, so this represents the basic electronic configuration. Then how we find valence electron? So the valence electrons are encircled by the red color. You can see here for the hydrogen there is one valence electron, for the helium there is two, for the lithium there is one, and for the beryllium there is a two, for the boron is three. And these electrons in case of Lewis dot structure represented by a dot. You can see here there are one dot, there is a two dot. So this represents the Lewis dot structure of atom, not molecule. If these atoms are combined together, they will form compound and molecule. So Lewis dot structure of important compounds. Yes, HCl, hydrochloric acid. You can see here from the table, hydrogen has a one electron that represented by red color, or the chlorine has a 7 electrons. Chlorine require one more electron to complete its 8 electron. Hydrogen require one more electron to complete its doublet. So they share together because both are non-metal. No one can lose their electron. The only way that they complete their 8 electron must be sharing. So there is a formation of HCl. So basically there is a type of bond which present between hydrogen and chlorine is covalent type of bond. Come to the next very important structure, water. Okay, and the life on the earth is because of only water. So we include this molecule here. You can see here oxygen has 6 electrons in the outermost shell because its configuration and electronic distribution is 2 and 6. So its valence electron contains 6 electrons. So it required 2 more electrons. That means it must share its 2 electrons. The rule of sharing is if you share 1 electron, you got 1 electron. If you share 2 electron, you got 2 electrons. You can see here oxygen required 2 electrons. That's why oxygen share its 2 electrons and form 2 covalent bonds. You can also estimate the number of covalent bonds formed during sharing by requirement of atom. If center atom require 2 electrons to complete its octet, that means it must form 2 covalent bonds. Now the third example is going to a methane, that is a major greenhouse gas. You can see here The central atom is carbon. First write the uh, valence electron of this carbon. So these are 4, and hydrogen is one of the each hydrogen. You can see here why this carbon is combined with the 4 hydrogen only, because complete it requires 4 electron to complete its octet. That's why it combined with the 4 hydrogen with the help of covalent bond. So basically we talk about this octet rule, but there is a for the everything in the universe there is a one is a good phase, another is a bad phase. There is a limitation of this octet rule. You can see here duplet. That means you already see here hydrogen and helium are the only two electrons in the periodic table which complete which want to complete their duplet only, and they are quite stable. For example, you can see here S2 molecule, which is quite a stable molecule. That's why is a limitation of octet rule. According to octet rule, hydrogen must have 8 electrons in surrounding, but in case of S2 molecule, both the hydrogen atom surrounded by only 2 electrons. That's why is the biggest limitation of this octet rule. Now second is expanded octet, that can be represented by sulfuric acid molecule. You can see here there is a central atom, that is sulfur, surrounded by more than 8 electrons. If you count the number of electrons, you got that there is a 10 electrons. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 12 electrons are there. 12 electrons are there around this central atom. And according to octet rule, the species which have 8 electrons is stable, but there is 12 electrons. That's why is an example of expanded octet. Come to the next, that is incomplete octet. If anyhow this central atom unable to complete 8 electron which surrounded, in that case is a case of incomplete octet. You have a very good example, that is boron trifluoride Bf3 molecule. The valence electron of boron is represented by a white dot, and these are 3. Well, fluorine is a element of group 17. Okay, so it has 7 electron in outermost shell, so it requires one more electron. That's why boron combined with the 3 fluorine atom. The basic theme about this is, consider in complete octet, that means less than 8 electrons. Consider boron is surrounded by 6 electron here only, that is 1, 2, 3, 4, 5, and 6. So only 6 electrons which surround the central atom. Even this molecule is stable, quite stable. Come to the next element with the odd number of electrons. Odd number of electrons. If we see here, there are nitrogen element which has 5 electron in its outermost shell, that means valence electron. So if we want to complete its octet, oxygen complete its 8 electron, but nitrogen will never. There is a one unpaired electron is there, that is a kind of odd number of electrons. So other drawback can be seen for the octet rule. The fifth one is it does not tell us about the energy of a molecule. That how you compare that Bf3 is more stable than hydrogen or some other elements. So it never tell us about the relative stability of it. Tell us about the stability of molecule, but do not tell us about the relative stability of molecule. And fifth one is, yes, does not tell us about the energy of molecule, that what energy is of molecule. The sixth drawback is it does not tell us about shape of molecule. That means whether it is a linear, pyramidal, square bipyramidal, and because of this shape of molecule reason, we have some different theories. We talk about it later, like molecular orbital theory, not molecular. Vesper is there, valential electron pair repulsion theory. Okay, so we balance bond theory. So we talk about it later. Come to the next. So this is all about today's lecture. So today we learn how to draw this Lewis dot structure. What is octet rule? What are the limitation of octet rule? So we have some questions and answers here. Who gave the term covalent bond? That is answer is Langmuir. What is covalent bond? So these are very basic questions. The important question is question number 5. Draw Lewis dot structure of carbonate and nitrogen nitrite ion, that is nitrogen dioxide anion. So you can see here this is carbon dioxide molecule. There is a two negative charge here and there is a -1 charge. So this two negative charge indicate that carbonate molecule gain two extra electrons, and these extra electrons are represented by this red dot. Okay, and in case of nitrate molecule, NO2 minus molecule, there is a minus one is there. Yes, there is a correction. You can write here -1. So this -1 represent here. You have to draw in such a manner. So this -1 represent that there is a one extra electron here. Yes, there is one extra electron here that gained by this nitrogen. Okay. So this is all about today lecture. Have a nice day. You can practice at your home by taking different examples of molecules. Okay. There is no shortage of molecular chemistry.